Sure. Good afternoon, everyone. Before I jump start into the discussion, I just want to know how many of you are familiar with ISO 26262. Please raise your hands. Wow, that's more than what I expected. And how many of you follow the ISO 262 process in your development process in your company? Okay, that's good. Yeah. So I don't have to deep dive into the standards here anymore. So why is this talk important? So as you have heard from some of the keynote speeches today and yesterday morning, that RISC-V is really getting into the automotive pretty much. So the CPUs are becoming very much part of the semiconductor in the automotives, in the cars. So there are more and more CPUs coming, and more of them are becoming RISC-V CPUs. So why automotive industry is interested in RISC-V CPU is not just that it is open, flexible, scalable, it's giving a better PPA and so on, but also they want to break the monopoly and the dangers associated with it. They want more options. Hence, automotive industry is very much interested in getting into the RISC-V. So yeah, but semiconductor design for automotive comes with a lot of baggage, where safety is very important, very critical. And how do we ensure safety is by following ISO 262 process, which I'm going to talk about. Oh, sorry. Okay. So just a note of thanks to my colleagues who are not here today. Poorva, Bhargava has done a lot of work on this, and Andrew Johnston, also safety manager, has given a lot of useful feedbacks on this work. Okay, so one other thing, I'm not going to do a lot of company marketing. I don't have any marketing or sales slides here. So it is more of a general talk. The slide content is more suitable for an interactive session, but I think the format here doesn't help interactive, so I just have to talk through, and maybe I have to take questions later on or offline. Okay, so this talk is more to create the awareness about the safety processes or the ISO processes to the RISC-V community, and to emphasize that why it is important to follow the ISO 262 process in any applications or any products that we are building towards safety or automotive, and try to call upon the RISC-V community and the ISO standards to collaborate, work with each other, to understand the challenges and the pain points from each other, and make things easier for RISC-V community to design products for automotive industry. So that's the primary aim of this talk. Okay. So what gives us the credibility today to talk about this topic here from Imagination is Imagination already has a proven track record of delivering high quality IPs for automotive markets as well as the consumer market. Many people may know that Imagination Technology is quite known for its GPUs. We were the primary or the sole IP provider for the GPUs for Apple till recently. As well as today we are getting into the automotive side, and we have prominent OEMs or tier 1s sourcing our IPs. So, and we have already a ASIL-D certification for our process. So earlier this year, our quality team and the safety team were successful in outlining all the processes and lay out all the processes, the development process to get the certification. So here is a proof of the certificate. And we also have ASIL-B certified GPU IPs already delivered to the automotive SOC customers. So at Imagination, we have already experts who know the safety process pretty well, and not only the process, but also what are the safety mechanisms in terms of hardware, what needs to be developed, how it needs to be developed. Those expertise is already available in-house. We are also have a licensed embedded CPU IP, which is our Catapult based RTXM 2200 IP already available. And we are in the process of taking this IP and making into a safety compliant CPU for the automotive segment. And what we have the future commitment to develop more products which caters to ASIL-B and ASIL-D compliant CPU IPs, as well as our GPU team is also working towards that. Okay, so the contents of the slides are, we are going to briefly talk about what are the strengths and limitations of RISC-V open source, and what are the functional safety related aspects in ISO 262, and the key challenges that we face in adopting ISO 262 for our CPU development. And I'll briefly touch upon what are the key considerations we need to have RISC-V hardware in safety critical applications, and quickly conclude on it. Okay, so RISC-V itself doesn't require any introduction, and ISO is, as many of you know, that it is a functional safety standard towards electronic and electrical systems for the road vehicles. So it primarily focuses on the road vehicle related standardization. So what are the key strengths of RISC-V ISA? Again, many of you may already know many of these things. It is a large community of architects and developers and validators coming together to develop the standard. So because of the nature, it's free in nature, there is definitely a cost benefit to the customers, and there is a plenty of open source design and verification components available in the open source that that product developers or the IP vendors can take and leverage on it and try to build the products faster. It is simple and modular and extensible. So again, from the keynote, you might have seen that there are plenty of extensions that are getting ratified, and newer extensions are getting added every day. So it is growing pretty fast, and this is one of the very key design feature for the automotive, where these RISC-V CPUs are easily scalable from embedded to the automotive to the HPC. So that is one of the biggest advantage of RISC-V ISA, and we have seen that it is very easy to build various configurations. Based on baseline configuration, you can keep adding extensions, you can keep adding features, you can easily configure based on what customer requires, and roll out a product in a shorter amount of time. And also from Imagination's CPU development team's experience, we have seen that the CPU developed on RISC-V is a lot more power efficient, consumes lesser area, and also has a better compute density as compared to our nearest competitor or the ARM solutions. So for further details, you can refer to this link available here, where or you can catch up with us to understand how we are getting a better PPA with the RISC-V ISA. And the other benefit is the multiple options that the OEMs and tier ones would get. There are a lot of IP vendors for RISC-V, and there are many open source resources available which can be leveraged. So these are the key strengths of why we have to go for the RISC-V ISA. So just want to touch upon this ratification life cycle here. Here we see that RISC-V has a very good process laid out for ratification, where the spec development is done by the industry experts, academic experts, and several design and development community who come together and develop the spec. And finally, it goes into the public domain for a very thorough review, wherein all the feedbacks are collected, and then the required changes are made. And finally, it goes through the technical steering committee and the board for the final ratification, and it gets rolled out for the community, for the hardware and the software developers to use it. So some of the challenges that we face or the limitations that we have with RISC-V ISA is that it is new and evolving. For the automotive industry, what matters the most is stability and standardization and to be proven in use aspects of things. But whereas RISC-V is still evolving and new, so there is a risk of like undergoing too many changes in a short span of time, and that can lead to some compatibility issues where newer extensions and enhancements may not be compatible, backward compatible, and there could be a problem with interoperability and in the complex associated systems. And the other part is we know that already there are interfaces we inherit from ARM ecosystem. So that again poses some sort of a risk in the long term. So there is a need for standardization of interfaces and compliances with the industry standards. The other challenge is the documentation and traceability part of the things. ISO requires very exhaustive amount of documentation, quality process to be followed. So whether in the RISC-V community, whether all this due process have been followed to make sure that the specifications or the products that they develop, it gets finally certified by ISO standard. So this making sure that we have a rigorous documentation review process and forward and backward traceability becomes a major challenge here. So a quick definition of FUSA for the people who don't know what is FUSA is about. It's a functional safety as defined by ISO 262. It is an absence of unacceptable risk due to hazard caused by malfunctioning of the behavior in the electronic system. So what causes the hazards is the faults or the bugs that can be there in the design. The root cause of these faults or the bugs could be of two kinds. One is the systematic fault. So systematic faults occur due to the gaps in the specifications or the design and the development stage. And the random faults are the ones that the faults occurs during the lifespan of the usage of the product. So in this talk, we are just focusing on the systematic faults avoidance because this itself is a large topic to cover. We are only talking about the process part of the things in this talk. Okay, so this also may be a chart which many people may be familiar. So this is the complete ISO 262 process documentation parts. It has more than 10 parts and various chapters. This is a exhaustive documentation that the functional safety managers will understand, and they drive the process of things. So what matters for the RISC-V community, especially for the hardware CPU developers, is this part 5 and few other parts here. So some of the parts are just primarily related to the management, and this part, yellow part, is focused on the development process, and the blue one is more about the supporting processes. So when we develop CPUs, we generally develop it as a general purpose IPUs. We may not be knowing who the customer is or in which SOC exactly it goes in. So we call that concept as developing the safety element out of context, SEOOC. So for the IP developers or the product developers or developing the IP without exactly knowing the end SOC or the customers, only these highlighted parts are applicable. So this simplifies us few process steps that we need not follow the entire process, only few applicable processes that we need to follow. So this is thanks to ISO, who has provided this kind of provision to simplify the process for the IP developers, especially in the RISC-V community, can leverage this. So the challenges seen in adapting ISO 262 for anyone who's not familiar with this, it's a very complex documentation that we have, and the time required to change the processes, sometimes we have to change the processes that we are already following to make it ISO 262 compliant. So that becomes another big challenge. Validation needs to have exhaustive, this validation has to be very exhaustive in terms of having all the cover points written, test cases documented. So this is one other major challenge. Traceability and documentation, which I mentioned, it requires quite an exhaustive amount of documentation, evidence providing to follow the ISO 262 process. And the tools, we need to know what tools we are using. We need to have the tool confidence level assessed to make sure that our certification process goes through fine. And the expertise in this area itself is it's a scarce skill set that we can get, who knows both ISO process and also the application domain. Okay. So what are the key considerations while maintaining the ISO 262 process compliance is, one is the intended function of use. So we need to know what for we are designing the product for, or what for we are adding the features, or why we are making a change. So that needs to be, we need to be very aware of that, and we need to do a detailed impact analysis for the change that we are trying to make. And the modification scope has to be well defined in terms of whether it is applicable to ISA or whether it is a design or verification or environmental things. And identify the source of the spec ISA. This needs to be identified and documented, what is our baseline, and you have to properly prepare the baseline before you take up the changes. And review the impact on the safety goals. So this, we need to understand how much of impact it will have on our safety goals or the technical safety requirements. This needs to be well documented and audited. Then we have to categorize the change that we are trying to do, whether it is a planned change or an unplanned change. And we have to list all the work products that gets impacted due to any change, whether it is the code that gets modified or the scripts, the documents needs to be very well understood. And we have to do some categorization also related to the impact that it's going to have on the change request. So ISO 262 provides the guidelines and the framework to assess the new changes and follow the systematic development process. We know that systematic development process is required very much to make sure that no bugs creep into the design. So yeah, we are concluding. So to make sure that the ISO RISC-V CPUs are becoming the most preferred choice for the safety critical applications for the advantages that I listed before. And but RISC-V community needs to understand about the ISO 262 process very well. And to avoid systematic faults, we need to follow the ISO 262 guidelines and frameworks that is laid out. And to simplify some of the process of development, we need to apply the concept of safety element out of context. That helps in focusing on the limited set of process and the procedures that we need to follow. Yeah.
All right.
So yeah, we are at the end of the presentation. Yeah. Thank you.
All right. Thanks very much, Ravi.
Thank you.